The next question that I must ask you is a series of questions. Please work with me on this. What is the height of the hound? 60 centimeters. Well done. Give yourselves all a gold star. What dog is 30 centimeters tall? Corgi. Excellent. Oh, you guys are brilliant. How tall is the Malamute? Beautiful. Which dog is 45 centimeters tall? No. No. I didn't ask for two answers. I want to know which dog is 45 centimeters tall. Please tell me.
The lab is 45 centimeters tall.
But I didn't say give me a bunch of dogs. Because I am looking right here and I'm seeing that it is the shepherd that is 45 centimeters tall. You are telling me it is the lab. But I can see quite plainly it is the shepherd. But I didn't ask for both. Which is singular?
Which one do you want?
I want the answer to the question that I am asking you. It is not a complicated question. Which dog is 45 centimeters tall?
The shab.
The lab and the shepherd.
Again, I don't know why this is so difficult.
The shab. It's the shab.
Let's try this. I have an eraser in my right hand. Which hand has an eraser? The right hand, because which means one thing. So, which dog is 45 centimeters tall?
Bo!
The lab is 45 centimeters tall.
But no, because the shepherd is 45 centimeters tall.
No, the hound is 45 centimeters tall because it's taller than 45 centimeters.
No, you sneaky. All right. The reason.
Wait, okay, so what if you have two erasers in your hand?
The reason I am being this way with you is because this relation is just that, a relation. If there was no shepherd here, could you tell me the dog that is 45 centimeters tall? Yes. If there was no lab there, could you tell me the dog that is 45 centimeters tall? Excellent. If I give you a dog name, can you tell me any of their heights? Yes. So the problem here is when you are given data from only one set, I give you data only from here, you cannot definitively answer my question, can you? Which makes this a relation. If it was such that this lab wasn't here, then this becomes a special kind of relation, and that special kind of relation is called a function. Okay? Anytime two groups of data are compared to each other, it is a relation. Sometimes it is a special kind of relation that is a function. Is everybody cool? All right. So you're going to turn your page over and we are going to talk indeed about what a function is. But before I do that, I'm going to call your minds back to approximately the 5th or 6th grade. If you were going to a school that still used ancient textbooks, you will remember something that looked like this. And if you had one of the slightly fancier textbooks, you had a drawing of a little conveyor belt or something here, and go away, and go away, go away. And on the conveyor belt were numbers. Yeah, knock yourself out.
Really?
Yes. She should have said go
yes.
for Carlson.
Jasmine Brar? Yes.
Dun, dun, dun.
Pardon. Could you please say that again? Pardon? Okay, Mr. Myers, the woman is asking.
A woman is asking.
Myers. I'm looking right at her.
I'm looking right at her, dude. For you.
Hey.
Now, that conveyor belt took the 7, dropped it into the function machine, and then you added 7 to get 14, then you multiplied by 2 to get 28, then you took away 3 to get 25, and 25 was what the function machine spit out at the end. But of course, because my computer sucks, I can't do my fun, where I take the 25 and ooh it out. Do you remember seeing some construction like that?
Yes.
And the textbook called it a function machine, most likely. And it called this the input, and it called this the output.
My textbook was no fun. It just called it an input-output machine.
Lame.
I know.
Input-output machine.
I didn't have a machine.
Now, oh, even lamer. So, just for fun, let's just take a quick second here. Now, of course, I have to stop the recording because I'm going to be going on to copywritten material. And if I put it on, you laugh, Rose. YouTube people took down one of my summer school videos because I showed a guy surfing. Somebody was watching it at YouTube. So we've all seen the function machine, or as is apparently the case, some textbooks boringly named it an input-output machine, which is super lame. But anyway, so a function is a particular relation whereby every input gives one and only one output. Okay? So, look back at the dog chart. What would you say is input? The dog name or the height? Which of those two sets would you consider to be the input if I were to ask you a question about this chart? Dog name. Abso-smurfly correct, yes? Yeah. Hound.
60.
Nice work. Chihuahua.
30.
Nice work. Corgi.
30.
Nice work. Lab.
45.
Shepherd.
45.
Malamute.
80.
Perfect. Now try going the other way around. 60. Nice. 13. Nice. Corgi. 30.
30. Corgi.
45.
Shepherd.
No. No.
It doesn't work because it's
Okay, it doesn't work, which is why this is not a function. Everybody cool? Okay, so.
Wait, so a function has to work back and forward, right?
No, a function only has to work input to output.
Okay. Yeah.
Here is what I mean. What if the only dogs on that chart were Lab and Shepherd, would it be a function?
It'd just be a malfunction.
It would be a malfunction, but in math there's a name for that. It's called a relation. Would it be, it's a relation, right? Because no matter what, if I input Lab, I get two outputs, 45 and 45.
Yeah.
If I input Shepherd, I get two outputs, 45 and 45. So that makes it a relation, right? All right, so now let's see. No, you're just playing with your hair. Okay. No, you were playing with your hair, though, up back here. See, I can't play with my hair up back there because I've recently found that bald spot. So I have to be very careful. No. Because I am married with children. There will be no comb over. There will be a shave.
Shave. Just get it right off.
All gone.
That would be quite the day.
Now, number 1. Each month of the year relates with a number of days. What are my two sets of data? Months, which are January, February, March, April, stop it, May. And I'm going to stop there, and I have a reason for stopping there. I lie. I need one more month.
I gotta do that.
Is everybody cool? And it would carry on to December, yes? What is the other set of data? Which are
31.
30,
Isn't it 31 sometimes? June has 38. Oh, wait, we're starting in June. I see.
April, June, and November. All the rest have 30. Shut it.
I don't know.
31,
We're so
And
bad.
28.
28,
To which we 28 is until my year brings us 29.
29. Those are the only options for months, yes?
Yeah.
Now, which would you say was input? Month or number of days? Month. If I input January, what is my output?
31.
31. January is input. Output is 31. Is it a function right now? Yes. One input, one output. February.
No, because. Yeah.
Does it matter? What are the options for February? It could be 28 or 29. When I input February, how many outputs do I get? 2. So is it a function? No. So right there, that makes it a relation. But let's pretend oddball February is out of there. Which, by the way, I would like to remind you all, 2020, 2 years from now, is the leap year. When February 29th rolls around, please remember that is a day that is owed to you. You have been depositing 4 minutes a day in the time bank for 4 years. Which means February 29th really should be a holiday for everyone. Because every single person working it has already lived that time and is owed that time and should do whatever they want that day.
That was actually very.
Then you've only had 4 birthdays, so don't tell me you're 16.
Do you know who
I actually know somebody that has
Yeah, I know.
She's born on the 29th.
Yeah.
Okay.
Okay,
Because when she
now.
was 16, they gave her a 4 before you
Yeah. All joking aside, March,
Wait,
30, 31, 20, 29.
30,
Wait, how's it 30?
31, 31.
31.
31.
January,
Now,
February,
let's
March,
take
30.
February out of the equation, right? February's gone. Input January, output 31. Input March, output 31. Function or relation? No, because when I say January, you know it's 31, but March is also 31. So when I say January, am I talking about this 31 or this 31?
But if you start with the months, then shouldn't it be a...
I only have 4 possible outputs, and I have 12 months. At some point, I'm going to have...
Then it's still not a...
Yes. Yes.
Oh, well, that's silly.
Everybody good?
Change it.
Everybody good? Okay, let's go to the next one. Every name on my class list refers to a student in the class. What are the two sets of data? What is set 1?
Name.
Name. What is set 2?
Person.
The person. Right?
It is a function.
Let's check. So, name. Taylor Carlson.
That's me.
Is it really?
Blonde girl sits right there. When I say Taylor Carlson, how many Taylor Carlsons are in the room? One. Her.
Wait, blonde girl that sits in the front though.
All girls in the front are blonde, except no, but she's slightly backset, so technically.
You know, it's an important part of this class that
All
I
right.
feel that you should be
The
like,
point I am trying to make, the point I am trying to make is, what is it?
It's me.
Is it a function or a relation?
It's a function.
It's a function. But let me ask you this.
Unless there's two people.
I am only going by last name.
Oh,
Oh,
well,
okay.
that's not a function.
There's like 70
So this way it's a
billion
function. What about last name? It's a relation because this classroom is chock full of sandoos. There's more sandoos in here than you can shake a stick at. Right? There's 4.
So it's me, Sandu, Armin Sandu, Ali Paul Sandu, and Parnger Sandu.
Wow, 4, just like I said. Amazing.
Wow.
If only we could have eliminated all that wasted time with just accepting that there were 4 sandoos in the room.
Like he actually has a
It's as though you're the math teacher, and the teacher is class.
Please? Please do. No, please do. You may talk to her. Carmen. Go. I don't care. Everybody cool with the last name thing? That makes it a relation. Now, what if it was first and last name?
I think we're good.
99% of the time we would be good, except in my homeroom, because I have 2 Jazreet K. Dillons.
Oh yeah.
Right down to the middle, not just initial, the actual name.
Core.
And the grade, and the age,
And
and the fact they're in my homeroom.
Wait, how do you tell them apart? How do
They
you know
look,
which one's which?
they look totally
No,
different.
but like on the list, how do you know which one's which?
Oh, I go by their student number. Student number.
But then
So,
how do they assign the student
now-
to the right person?
Wait, how do you know which one comes first and which one comes second?
99% of the time, if I go by first and last name in a classroom, is it going to be a function?
Yeah.
Yes. If in our school, if I go just by last name, almost never. There's a million Sanders, there's a million Gills,
Yeah.
right? There's a million.
There's some new fellas in here.
Yeah, this place is lousy with Rufosses as well. All right? Everybody cool? If I only go by first name,
No.
Then
We're
still most likely not, right? How many times have you been in a class where there's been a Johnny Q and a Johnny R? Right? A million times.
I've been Sarah J most of my life.
Okay.
Have you ever had a sandwich?
Dramatic.
No.
I don't know any of them. Or my last name.
I knew I was Samantha. It's like,
All right. Everybody cool? Okay. So now we are aware that our sets can be split into inputs and outputs, yes? Which, by the way, in case anyone cares, you know on a switch for something, you see an I and an O?
Oh, yeah.
It's not input-output. It's 1 and
you were
0.
gonna say it is input,
No,
but I
it's 1 and
got-
0 because it's binary. But that's beside the point. On or off. That's how computers talk to each other. At any point, or at any rate, let us move on. We now know that input and output are definitely different things, yes? They cannot share the same name. So, we have given them names. Dependent variable and independent variable. The dependent variable is the output. Because you cannot arrive at a dependent variable unless you have been given an independent variable, right? The output is the dependent variable because the independent variable, and I'm lazy, I'm just going to write IV. the IV, I'm going to call this the DV, call this the IV. The IV
The plan.
has to be where we start. Right? The dependent variable changes because a variable by definition changes. It's variable. The dv changes when the iv changes. If the iv doesn't change, the dv doesn't change. And think back to the dog chart, right? If I keep saying hound, what's the output? 60. Hound.
60.
Hound.
60.
Hound.
61.5.
Guys, listen to me. Hound. Okay? Shut up and listen. Hound.
60.
Understand? Did the IV change? So the DV didn't change. Everybody with me? Corgi.
30.
Corgi.
30.
Chihuahua.
13.
Oh
Lab.
my god.
45.
Malamute.
Aggressive.
80.
Understand?
I didn't know what I'm like.
Oh, I can imagine like Kahoot in this.
Yeah,
Now, listen to me. Listen to me. Listen to me. Great Dane.
Oh, probably like
Can't do it. Why?
100.
You don't know that?
Because you don't have the data. Everybody with me?
Yeah.
Working the other way doesn't work, does it? 45. Don't bother.
Oh no.
Right? Okay.
A dog.
So, the independent variable is the input. The IV, we already know the IV is where we start, and the DV changes when the IV changes. Son of a stupid short days. Still no homework. See you tomorrow.